Welcome to this stream. Let us look at chemistry paper 3. First, remember to like, subscribe. It is not costly, you just subscribe and you do like this, and then you are good to go. Welcome, let us look at this video. Follow step by step. You are provided with solid A. Carry out the following tests and record your observations and inferences in the spaces provided. Place all the solid E in a boring tube. Add about 10 centimeters cube of dilute nitric acid. Warm the mixture and then allow it to stand until all the solid dissolves. Add about 10 centimeters cube of distilled water to the solution and shake. Retain the solution for test B and C. So we are adding dilute. You are adding dilute nitric acid to salt E that you don't know. So we expect that the salt could be something like a carbonate. So we expect to see effervescence because we are adding an acid. That is the expectation, that we will see effervescence or you will not see effervescence. So whenever you are adding an acid to a given solid, you are adding an acid, just expect effervescence. If there is no effervescence, then it means there is no carbonate inside there or sulfite. So for this one, the observation was that there is no effervescence. So if there is no effervescence, it means that the carbonate, the sulfite is absent. If there was effervescence, then the carbonate and the sulfite is present. That is the observation number 1 for adding the acid. And after that, you are supposed to add water. What happened? Did the solid dissolve to form a colorless solution, or which color? What was the color after dissolving in water? So for this one, that is another observation you need to make. Solid E dissolves to form a blue solution. So E dissolves to form a blue solution. Once a blue solution is formed, don't think twice. That one simply means the copper 2 ions are present. That's what it means. Use about 2 centimeters portion of solution obtained in 3A for each of the following tests. To the first portion, add 2 to 3 drops of aqueous barium nitrate. We are adding barium nitrate. Remember, we have talked about barium nitrate. We expect a white precipitate or no white precipitate. So for this case, there was no white PPT. No white PPT formed. You can say formed. No white PPT formed. Then it means there was no carbonate, there was no sulfite. Of course, to make a we have said that these ones were absent. So here now, what we are remained with, we are going to say that there is no sulfate. This one is absent. The sulfate ion is absent, right? Because we are not going to again write the carbonate or the sulfite here that it is absent. Already we have said up here that it is not there. Therefore, we write this one is absent. That shows maturity and understanding of the concepts. To the second portion, add 2 or 3 drops of aqueous lead nitrate. We are adding lead nitrate. Now remember, from here we have said there is no carbonate, there is no, so let us see the observation here. When we added lead nitrate, when you are adding lead, remember, you expect a white precipitate or a yellow precipitate. Like I said on the other video, lead iodide, if there was iodine inside there, it will form lead iodide, which is a yellow precipitate. If there is a chloride inside there, it will form lead chloride. So let us see the observation. No yellow PPT formed. So if there is no yellow PPT formed, it means that the iodine ions was absent. No white PPT formed. Now, if there is no white PPT formed, then we say there is no chloride ion. Chloride ions was absent. Sometimes you can even say bromide ion, because bromide ions also formed a white precipitate with lead. Absent. These two ions were absent. Now the question is, why didn't I say the sulfate, the sulfite, and the carbonate? It is because already from the above experiments, we have already said that the carbonate, the sulfite, and the sulfate are not there. Therefore, we are not going to repeat ourselves. We only include the anion or the cation that we have not mentioned. Therefore, this means this chloride is absent. To the third portion, add aqueous sodium hydroxide dropwise until in excess. We are adding sodium hydroxide until in excess. Sodium hydroxide until in excess. The blue PPT for blue PPT is formed, which does not dissolve or insoluble in excess. So a blue precipitate is formed which does not dissolve in excess sodium hydroxide. Therefore, that confirms that also tells you that the two copper 2 ions are present. So long as it is a blue precipitate, it confirms copper. Copper 2 ions are the only ions which are blue in color. Place about 3 centimeters of aqueous ammonia in a test tube. To the fourth portion, add all the aqueous ammonia from the test tube dropwise. Place 3 centimeters of aqueous ammonia in a test tube. To the fourth portion, add all aqueous ammonia from the test tube dropwise. So dropwise. So if you are putting you are adding dropwise, don't expect them to tell you until in excess. Dropwise, you put it dropwise and then you end in excess. That is the, so here a blue precipitate, a blue PPT is formed. It started dissolve in excess to form a deep blue solution. A deep blue solution. That tells you it is copper 2 ions that are present. So when you find things repeating themselves like this, don't worry. To the remaining solution on the boiling tube, add all solid G provided. Shake the mixture for about 2 minutes, after which, filter the mixture into a boiling tube. Retain the filtrate for tests 1 and Roman 2. So a blue solution, remember the blue solution, so the E formed a blue solution. Now the blue solution, the observation is that blue solution changes to green. Changes to green. So if the blue solution changes to green, it means that the copper ions has been displaced. Displaced by what? What is green? The green is the ion 2. Therefore, it means that copper 2 has displaced. It's been displaced by G. Then a brown residue is formed, or remains brown residue. Then another thing is that after filtration, we have a green filtrate. A green filtrate. And then you also can add that Cu2 positive reduced by G. To about 2 centimeters portion of filtrate, add aqueous ammonia dropwise until in excess. You're adding aqueous ammonia, that is sodium hydroxide, dropwise until in excess. Then green PPT is formed, which is insoluble in excess. Insoluble in excess. That one is ion 2 present. Ion 2 is present. To about 2 centimeters portion of the filtrate, add 2 to 3 drops of dilute hydrogen peroxide solution. Hydrogen peroxide solution. So green solution changes to brown. So green solution changes to brown. So that means ion 2 oxidized to ion 3, because ion 3 are the one which are brown. So you can say ion 3 formed. Ion 3 formed. And there you expect a effervescence. You expect a effervescence. Yeah, you don't have to put anything there.
Thank you very much. Let me finish drinking tea and I will put another one. Asante, nimeshukuru.